December 2017. A cigar-shaped visitor slices through our solar system. No warning, no tail, and no easy explanation. 2 years later, another drifter appears, trailing a bright comet-like tail. And now in 2025, something even bigger, possibly 20 kilometers wide, is headed straight toward Mars's orbit. This is 3I Atlas, the third confirmed object from beyond our solar system. But here's the twist. It's nothing like the others. Now, we don't usually talk about asteroids, but when something enters into our cosmic backyard from another star system and behaves in ways we can't explain, that's not just space science. That's a mystery worth checking out. And to see why 3I Atlas is the most exciting yet, we need to rewind to the very first visitor. You're about to discover how these mysterious cosmic visitors, one silent, one screaming with gas, and one enormous, are flipping our understanding of space on its head. And to see why 3I Atlas is the most exciting yet, we need to rewind to the very first intruder. October 2017. Telescopes catch something strange. Long, narrow, spinning oddly, and moving fast. But it wasn't spinning like a top. It was tumbling, like something tossed in zero gravity. No glow, no tail. Just a shiny object reflecting sunlight and moving in a way no ordinary rock should. Then it got weirder. After swinging around the sun, it sped up. But there was no sign of outgassing, no vapor trail, no dust plume. It just accelerated. Theories piled up. Was it a fragment of hydrogen ice, a nitrogen iceberg, a chunk of alien tech? No one could agree. But one thing was clear. It didn't behave like anything we'd seen before. And as it drifted away, out of reach, scientists were left with more questions than answers. But they wouldn't have to wait long for the next mystery. In 2019, a telescope picked up something that looked more familiar. A bright head, a long tail, and a gentle arc through the sky. A textbook comet, except it wasn't from around here. It was coming in hot from interstellar space. Unlike Oumuamua, Borisov behaved exactly how you'd expect. It spewed gas and dust, trailed a long glowing tail, and followed the predictable path of a comet. But its chemistry held surprises, substances richer in carbon monoxide than any comet we'd seen locally. That meant it may have formed in an environment far colder than our outer solar system. It was comforting in a way, proof that other star systems likely create comets just like we do. But that also made Oumuamua seem even stranger. Was it a one-off anomaly, or was it just the first of many weird ones to come? That question loomed large until 3I Atlas arrived. Summer 2025. Astronomers spot something fast and faint moving near Jupiter. Early measurements suggest it's massive, somewhere between 10 and 20 kilometers across. And like its predecessors, it's on a hyperbolic trajectory, meaning it came from outside the solar system and won't be staying long. Unlike Oumuamua, 3I Atlas has already started forming a tail, but it's still early, and its full behavior remains a mystery. What makes it extraordinary is its size. It's at least 10 times larger than either of the first two interstellar objects we've seen. This one isn't just a visitor, it's a potential Rosetta Stone. And in just a few months, when it nears its closest approach to Mars, we might get our first detailed look at the surface of an interstellar object. But size isn't the only thing that makes 3I Atlas so intriguing. Let's break it down. Oumuamua, less than half a kilometer. Borisov, roughly a kilometer. 3I Atlas, up to 20 kilometers. That's not a rock, that's a planet killer. The difference in scale changes everything. Bigger means more complex internal structure, more heat retention, and possibly more trapped gases waiting to escape. It could mean a thicker crust, strange magnetic properties, or even signs of erosion from a completely different kind of star system. And because this one's big and bright, we get more time to study it. Which brings us to how these things move. All three of these objects entered our system on hyperbolic paths, meaning they're not looping back. They're on a one-way trip. Oumuamua came in fast and left even faster, accelerating mysteriously. Borisov followed a calmer curve. But 3I Atlas? It's flying at around 68 kilometers per second and gaining speed as it slingshots past the sun. That's almost 40 miles per second, fast enough to cross the continental U.S. in under 2 minutes. The faster an object moves, the harder it is to study. But 3I Atlas is so large that even at this speed, it's staying within view longer. That gives us a rare window to learn before it disappears forever. Next, we turn to the most bizarre detail of all, what's coming off these objects and what that tells us. Oumuamua had no visible tail, none, but it still sped up as if something pushed it. That raised wild possibilities, like thin sheets of ice releasing invisible hydrogen, or an alien light sail catching solar radiation. Borisov, on the other hand, was all gas and dust, classic comet behavior. It screamed, "I'm natural," but still carried new chemistry we hadn't seen in our solar system. 3I Atlas is somewhere in between. So far, a faint coma and a short tail, but that could change dramatically. As it gets closer to the sun, the heat could trigger explosive outgassing, revealing more about what it's made of and where it came from. But we don't just want to look at the tail. We want a real picture. And that might actually happen. Here's what's exciting. As 3I Atlas cruises past Mars, it might get close enough for orbiters to snap images. Not just light curves and spectrographs, but actual photographs. That would be a first in human history. A close-up look at an object from another star system. The odds are slim. The object is faint, fast, and moving unpredictably. But if the timing and trajectory align, it could change everything. Because now it's not just about watching these objects, it's about chasing them. Every interstellar object is a message in a bottle. Oumuamua told us that not everything out there follows the rules. Borisov told us that comet making isn't just a local phenomenon. And 3I Atlas? It might tell us how different, or how alike, other solar systems really are. Do they form comets the same way? Do their rocks carry similar isotopes? Are we a cosmic average, or a galactic oddball? These aren't just academic questions. They're clues to our origins. And with every new object, we get a bit closer to answering them. This might be just the third interstellar object we've spotted, but scientists estimate that thousands fly through our solar system every year unnoticed. So why are we only seeing them now? And what happens when we spot one that's headed straight for us? That's a story for another time. But first, let's wrap this one up. 3 visitors, one silent and strange, one bright and icy, one big and still revealing itself. Each of them entered our solar system uninvited, and each left behind more questions than answers. But they've also opened a new frontier, the study of objects from other star systems, drifting through the dark like messages from places we can't yet reach. One day, we might send a probe fast enough to catch one, maybe even land on it. Until then, we watch, we wait, and we wonder, because the next one might change everything.